Nice having you again, my friends, here on Will EduTech. And in this video, we'll be looking at rule number 1, the rule of multiplication when working with indices or exponents. Now here it states, when multiplying indices or exponents of the same base, you add the powers, okay? And here we have an example in its general form. Here we have a base a raised to a power of m multiplying another base a raised to the power of n. And if you notice, since base a was common in both cases, then we just simply say this is equal to our common base a, and we just simply took the powers, the m and the n, and we just simply add them together. Now we're going to be looking at some activities now just to reinforce this rule and to show you the general idea behind it, okay? Because we just don't want to give you a rule, but to show you the concept behind the question, why do we add powers when working with indices? However, a very key instruction to make note of is here. We're going to be simplifying the following, leaving our answers in index or exponential form, okay? And we'll get into that as we go along. Now let's look at an example. Let's look at the first example. Let's say we had a 4 raised to the power of 2. Let's say we have 4 raised to the power of 2 multiplying a 4 raised to the power of 3. And this is example number 1, okay? Based on what the instruction is saying, my friends, they are saying here that whenever we have a common base, and I would like you to pay special attention to this phrase here, same base, because the basis has to be the same. Now if you notice, we have a common base 4, so simply all I'm going to do, I'm going to rewrite my common base, and I'm just going to take my powers, guys. I'm just going to take the 2 there, 2, and I'm just going to simply add it to the 3, okay? And that is equal to 4, a base 4, my common base 4, and that would be to the 2 plus 3, that would be 5, okay? So my answer is 4 rather, raised to the 5th power, okay? So this is our answer. But why do we add the powers? Let's just look at the general idea behind it now. A second method that we could use to work out the same problem, okay? And this is a second method. If you notice here, my friends, I have a 4 raised to the 2nd power, okay? So 4 raised to the 2nd power can also be written as 4 times 4, okay? And if you notice, that is multiplying 4 raised to the 3rd power. And 4 raised to the 3rd power can also be written as 4 multiplying itself 3 times, okay, as we had looked at it in the video before where we introduced exponents, okay? Now what this is really saying essentially is that since I have a common base 4 in all cases, if you notice, I have all 4s multiplying themselves right across, so I'm just going to simply put back my base 4, okay, and then I am just going to count the number of 4s I have. Basically you're just simply adding them up. So I'm saying this is 1 4, that's 1. Let me change the color. So simply we're saying this is 1, that's 2 4s, that's 3, 4, and that's 5. So since I have 5 4s multiplying itself, then I'm simply going to raise my base 4 to the power of 5. And if you notice, in both cases, we arrived at the same answers. Okay, my friends? Now, let's just look at a second example. Like to give you more than one example so that you can feel a lot more comfortable when working with these topics. Now, let's say, my friends, let's say we had a fraction, okay? Let's say we have a half, 1 upon 2, okay? And 1 upon 2, let's say it's raised to the 4th power here. And I'm multiplying 1 upon 2. And in this case, it's raised to the 2nd power, okay? Now, again, based on the rule, what they say that when multiplying, if you notice, the common base in this case is a fraction. It's a half, okay? So I'm just simply going to take my 1 upon 2, which is a half, and I'm just going to add my powers, okay? Rewrite my common base as I did before, okay? And I'm just simply going to take my powers. My first power is 4, and I'm just going to simply add my 2nd power to that, which is 2. So this is equal to, my common base is a half, so I'm going to rewrite 1 upon 2, that's the common base, okay? And then when you add the powers, 4 plus 2, that would give you 6. So this is a 6, okay? So this would be my answer, okay? A half raised to the 6th power. Okay, and I mean, another way of looking at this is a half multiplying itself 4 times. So just to reinforce it, you could simply say this is a half times a half times a half times a half. Okay? And let me just change the color here. Multiplying, for this multiplication sign, I'm just going to use a green. Multiplying a half 2 times. Okay? So let's just write that here. So you'll be saying multiplying a half times a half. Okay, my friends? So we have 4 halves here multiplying itself. So we have 1, 2, 3, 4 halves. And then we have another 2 halves. 5, 6. Okay? So if you notice, in both cases, we have the same thing. The base is common, which is a half, 1 upon 2. So let's just put that in a bracket to show that the 1 upon 2 is raised to the 6. Both my numerator is raised to 6 and both my denominator is raised to the 6th power. Okay, so those are 2 examples. Let's just look at another example, okay, because I like to change it up a bit so that you can be pretty much comfortable with these kind of questions when you get them in an exam. Okay, so let's say in example number 3, let's say I had a 5 raised to 1 upon 2 raised to a fraction now, and that is multiplying a 5 raised to a quarter. Okay, let's just change it up a bit. This is simply the same. You would say the base is common. The base, I have a common base 5, so this is 5 raised to a half. Okay, and since we are multiplying indices of the same base, we're just simply going to add the powers plus a quarter. Okay, when we're adding fractions, we find our LCD, which is the lowest common denominator. So here I'm going to say 2 into 4, that goes 2 times. So I'm going to multiply my numerator by 2. So I'm saying 2 ones, that would give me a 2. So let's just put that 2 here. Okay, and then I'm saying 4 into itself goes once, and 1 times 1 would give me 1. So that's a 1 there. So this would be really equal to 2 plus 1. That would give me a 3 upon 4. So really, my friends, what we have left over here is my common base 5. If you notice, I've been working with a common base 5 there and there. So I'm going to say my base 5 is now raised to a fraction of 3 upon 4. Okay? Let's look at another example, my friends, and let's just change it up a bit now. Let's say in example number 4. Let's say I have a 2y and I'm multiplying that by a 4y raised to the 3rd power. Okay, and let's say they ask us to simplify this, leaving our answers in index form. Now if you notice, we have some numbers here, so we could just simply go ahead and calculate the numbers. We have a 2 times 4, that would give us a 8. Okay, so we have a 8 there, but if you notice, I have a y here and I have a y to the 3rd power, or y cube there. Now remember, in the previous lesson I said that if you see a variable standing by itself, then it simply means, you just simply ask yourself, how many y's am I seeing here? Well, I'm seeing 1 y, so obviously that would be the power that y would take. Okay, so this is y to the 1. So in calculating this, if you notice here, I am multiplying a common base y. Okay, so I'm just going to simply rewrite my base y, and then I'm going to take my powers. This is y to the 1, so I'm going to say y to the 1 plus, since I'm multiplying, okay, plus a 3 there, because this is y to the 3. So really, my friends, this would be 8y, and I'm just simply adding my powers. 1 plus 3, that would give me a 4. Okay, and it's basically that easy. I hope you get the general idea of how to deal with indices when working with them. Now, my friends, before we go, a very important piece of information I would like for us to pay special attention to right now is the fact that in the instructions we stated that we would leave our answers in index or exponential form. Now if you notice my answers, okay, my answer, for example, in number 4, my answer is 8 and 8y to the 4th. If you notice, that's in exponential form. If you notice my answer for part 3, I have 5 raised to a power, okay, of 3/4. And if you notice again, my answer for part 2, I have a half raised to the 6th power. And also for number 1, 4 is raised to the 5th power, okay. So that's what we mean when we're saying we're going to be leaving our answers in index form, okay. It's a base raised to a power. Notice we didn't calculate the value of 4 to the 5th or a half raised to the 6th, okay. We left the answers just like that in exponential form, okay. Hope that was useful. See you in the next video where we'll be looking at the second rule of division, okay. Feel free to ask a question if you're still not sure, and we'll get back to you as soon as possible. Bye bye.